Assalamu alaikum everyone. In this video we are going to learn the three ways to check a given relation is a function or not. Every function is a relation, but every relation may or may not be a function. This means function always implies a relation, but a relation may or may not be a function. Right? Okay, so there are three basic ways to check a given relation is a function or not: by using ordered pairs, by using graphs, and by using equations. Let's begin with the first way. Okay, the first way to check a given relation is a function or not is by using ordered pairs. Okay, if we have given a relation in terms of ordered pairs, then the given relation is a function if its domain is unique. So the domain must be unique. Then we can say that the relation in terms of ordered pair is a function. Let me take an example of a relation R in terms of ordered pairs. Let's say 2, 1, 3, 4, and 8, 5. Let's see the given relation is a function or not. So we need to find the domain, and the domain must be unique. So what is a domain of ordered pair? So the x coordinate is basically the domain. So here the x coordinate is 2, 3, and 8. So 2, 3, and 8 is the domain, and the domain is unique. So we can say that the given relation is a function because its domain is unique. Let me take another example of a relation, again in terms of an ordered pair. Let's say 3, 8, 4, 9, and 3, 1. Let me find out its domain. So the domain is 3, 4, 3. So we can see the domain is not unique. 3 is repeating twice. So means the given relation is not a function because its domain is not unique. Right? Let's move to the second way. Okay, the second way to check a given relation is a function or not is by using graphs. Like if we have given graph, then we can say that the relation is representing a function if the graph satisfies a vertical line test. So the graph must satisfy a vertical line test. Now what is vertical line test? Vertical line test is a test when we have given any graph and we draw a vertical line on the graph, and when the vertical line meets the curve at just one point, then we can say that the vertical line test is satisfying. Otherwise a vertical line test fails if it intersects the curve at more than one point. Let me take some examples of graphs. Okay, we have given two examples of graphs. Let's see the given graphs are functions or not. So we need to satisfy a vertical line test. So let me draw a vertical line on the first graph. You can draw a vertical line at any point. Okay, let's draw the vertical line on the second graph as well. Okay. Now let's see which graph is satisfying a vertical line test and which one is a function. So we can see in the first graph it's a circle, and the vertical line cuts the circle at 2 points. The first point, and this is a second point, right? So since the vertical line is cutting the graph at 2 points, it means the vertical line test is not satisfying. So the first relation is not a function. And we can see in the second graph it's a parabola. After drawing a vertical line test, it just cut the curve at one point, so the given graph is a function. So we can say that the first graph is a circle, that is not a function because it is not satisfying a vertical line test, and the second graph is a parabola and it is a function because it is satisfying a vertical line test. Let's move to the third way. Okay, the third way to represent a given relation is a function or not is by using an equation. Okay, we can say that the equation is representing a function if we can say that for each input output is unique. It means when we have given an equation, we substitute an input and when we have got a unique output, then we can say that the given equation is representing a function. Let me take an example of an equation. If I have an equation y equals to 2x plus 3, let me give an input. If I would like to give an input of x is equals to 4, right? Let me solve it and solve the output. Y equals to 2 times 4 plus 3. So y would be equals to 2 times 4 is 8 plus 3. So here y is equals to 11. So when the input is 4, the output is 11. So for each input the output is unique. Then we can say that the given equation is a function. Right? Okay, let me take another example of an equation. Let's say x square plus y square is equals to 9. Okay, let me give an input. X would be equals to 1. So just substitute x equals to 1. So 1 square plus y square equals to 9. So 1 square is just 1 plus y square equals to 9. So y square would be equals to 9 subtract 1. So we can say y square is equals to 8. Now to solve for y, we have to take a square root on both sides. So square root of y square and square root of 8. So the y would be equals to positive and negative of square root of 8. So you can see when the input is 1, the output is positive square root of 8 and negative square root of 8. We have two outputs. Since the output is not unique, so we can say that the given equation is not a function because it is not generating a unique output for each input, right? So these are the three ways to check the given relation is a function or not, by using ordered pairs, by using graphs, and by using equations. I hope you understand all the three ways clearly. If you want to watch more and get updated, then please subscribe to my channel and press the bell icon for the latest updates. Thank you. See you in my next video.